I appreciate you stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Rotel RB-1090 power amplifier. Rotel sold these between 2004 to 2006 at a list price of $1,991, which would be about $3,100 in August 2023. It was rated at 380 watts per channel into 8 ohms at not more than 0.03% THD, and into 4 ohms it was rated at 700 watts per channel at not more than 0.03% THD from 20 hertz to 20 kilohertz. It is a massive piece of gear as far as amplifiers go, weighing in at 84 pounds, and it's about 17 by 10 by 16 inches. So it's a pretty big piece of gear, and it's not easy for somebody like me to move very much by himself. So we'll do a little tour of the front. There's not a lot going on in the front and in the back, and then we'll take the cover off and look inside it, and then I'll show you the data and give you my listening experience with this particular unit. Here is a close-up view of the Rotel RB-1090. Not a lot going on. We have a power button here that you press in. It has an LED right above it that stays red while it's powered on. When you first press it in, you will see LEDs come on the left and right channel for the protection circuit. Once it determines there is not a fault, you will hear the relays click on, and then those lights go away. In my testing, they never came on. You also have your THX certification. You got to have that. Here is the business end of the RB-1090, and I should point out that this is a dual mono design. Each amplifier is powered by its own power supply, and so it's really two amplifiers in one. Starting on the right, we have our unbalanced RCA input, and that is gold plated. We have our XLR balanced input there, and here is our switch here that selects whether we are in unbalanced or balanced mode. Likewise, going over to the left channel, balanced and unbalanced input, we have our removable IEC power cord. We also have these feet on the corners. Now, in theory, you could stand this on top of the feet. I'm not really sure why, but you could if you had some 90-degree bends to clear your wiring and cables. But I guess that's why they put them there. So our speakers are connected here. This is the right channel, this is the left channel. Now, these are electrically the same point. The intent is either to use them for bi-wiring. If your speakers are actually bi-wired, you could connect directly to here. And you could also run another set of speakers. So you could run two sets of speakers off of each channel. There are no A/B switches for the speakers. You just want to make sure that whatever load you have hooked up to this, it is at least 4 ohms. They are very nice terminals as far as the connections. They're 3-way binding posts, and it's very heavy-duty, first-class speaker wire connectors. Here is what the inside of the Rotel RB-1090 looks like once the cover has been removed. Right here is our right channel circuitry, and these are NPN output transistors. PNP transistors are on the bottom side of the circuit board, and you can see we have great big heat sinks here, and this would be our left channel output and input side. Actually, our input is right here for the unbalanced input. We have PNP transistors here at the top, so the NPNs are down below. There's a total of 4 PNP and NPN transistors for each channel. Now note we have huge heat sinks here and here for the output devices. Right here, the front heat sinks don't really do anything. They're just basically for show. There might be a little transfer off the edge here, but for the most part, those heat sinks do absolutely nothing other than look impressive. That would be a little nit. You can see that it's very well constructed. So we have 4 large capacitors for each channel, and in this case, each of these big capacitors are 22,000 microfarad at 100 volts. So there's 2 22,100 microfarad capacitors for the plus B supply and then two 20,000 microfarad 100 volt capacitors for the minus B supply, and that's for each channel. So this has a lot of capacitance storage per each channel. Also, you can just see that it's constructed real nicely. They did a really good job. It looks like it would be fairly easy to service. Now, one little thing I noticed, and I'm going to try to zoom in on it if I can. Right here on this resistor, we have wires soldered to the legs, and on the right channel we have the same thing. So I think that's kind of odd. In the industry I would call those white wires, but anyway, that's just kind of a little bit odd thing. But they use a lot of push-on connectors. There's a lot of fusing going on, a lot of good connections with I'll call them ground, with grounding features and the way they connect with bolts and stuff. So the construction is really good on it, and I'm going to try to zoom in on the circuitry in just a moment. So here we have another angle of the inside, and I think you can kind of just see these bus bars here between the capacitors. You have one here for these two capacitors and another here. You can also see we have fuses. I believe they're actually 18 amp fuses, and it kind of just gives you a little different look at the inside, and I'm going to try to get even another view. And I am just kind of free-handing this view just to kind of look around it a little bit more as to what's going on. It does have a couple of adjustments. You can see those two little pots there for adjusting the DC offset and bias voltages, and that's kind of just what it looks like. The other channel is the same. Our first plot shows the RB-1090 putting out about 5 watts into 8 ohms, and the gain is about 29.5 dB. Our THDs are less than, we'll say, call it 0.03%. Worst case, SNRs are around 83 dB, and the THD plus noise is better than minus 74 dB. Here we have the RB-1090 putting out about 5 watts into 4 ohms. And in this case, you can see the THDs about, we'll call it 0.02% for the left channel and 0.005% for the right channel. SNRs are up around 80 dB. And depending on which channel, the THD plus noise is minus, we'll say 72 to minus 80 dB. And this is at 1 kilohertz. Here we have the frequency response of the RB-1090, and this is from 10 hertz to 30 kilohertz, and this is with it putting out 5 watts into 8 ohms, and it's looking pretty good. The channel balance is within less than 1/10 of a dB, if that. At the low end of the band at 10 hertz we're down maybe half a dB, and at the high end of the band we're down maybe 0.3 of a dB. So overall this looks really good. Here we have the frequency response of the RB-1090 with it putting out about 5 watts into 4 ohms. The frequency range is 10 hertz to 30 kilohertz, and at 30 kilohertz we're only down, we'll say 0.4 of a dB at 30 kilohertz and also at 10 hertz. The channels are balanced to within about maybe a little over 1/10 of a dB, 0.2 of a dB, let's call it. So it looks pretty good. Here we have the RB-1090 putting out about 380 watts into 8 ohms at 1 kilohertz. And you can see our THDs are about, we'll call it 1.5%. The SNRs are around 63 dB, and the THD plus noise is right around minus 37 dB. Our gain is still at about 28 dB, and you can see the all the harmonics that are generated. Let me get rid of the left channel. You can see the right channel looks about the same. So this thing is spec'd at 380 watts into 8 ohms at 0.03% THD or less. So that definitely is not meeting that requirement. I'm going to go ahead and bring up the harmonics so you can kind of see them. This is a plot of the harmonic. Here is our second or even harmonic, and it is less than the odd or third harmonic, which is kind of what you would expect with a solid state amplifier. So I brought the input signal down a little bit, and now we're at about, we'll call it 355 watts into 8 ohms. And look at our THDs are less than, we'll call it 0.1%. The SNRs are looking at, we'll say 88 to 91 dB, and the THD plus noise is minus 61 to minus 73 dB. And it looks much better here at 340 watts. I guess it's dropping down maybe as it's warming up a little bit. Here we have the RB-1090 putting out about 700 watts into 4 ohms. Now the specification is for it to put out 700 watts into 4 ohms, but with not more than 0.03% THD. We obviously are at about 1.5% THD now. If you were playing music this loud, I don't know that the THD would really be noticeable, but it is a spec. Your SNRs are right at 59 dB, we'll say, and the THD plus noise is minus 36, 37 dB. I'm going to lower the power level a little bit and see how much improvement it gets. So this isn't so bad at 635 or 640 watts, where we'll call it 0.1% THD. SNR is pretty good, 88, 89, and the left channel's THD plus noise is about 20 dB worse than the right channel. And the amount of current that we're drawing, and we're drawing about 14 amps according to the kilowatt ammeter that the RB-1090 is plugged into. This plot shows the THD versus frequency for a couple different output power levels, and that's into 8 ohms. And here we can see that the RB-1090's worst case THD is maybe a little over 0.1%, and this would be for, it looks like, the 75 watt output power case. Actually, it does better with the higher power as far as THD, but 0.1 is pretty darn good in my books. You're certainly not going to hear that. And for the most part, it's probably less than about, if you look at the point right here, it's probably about 0.04%. I would say the majority of the frequency and power levels are less than that. Now, it's not better than the 0.03% as we get up to the higher power levels, but I would say this thing is doing really pretty darn good. Here we have the output impedance of the RB-1090 from 10 hertz to 20 kilohertz. And if you divide 8 by the number for the left channel, you would come up with a damping of about 36. And if you divide 8 by the impedance for the right channel, you would come up with a damping factor of around 60. Both of those are way short than the datasheet claim that was a damping factor of greater than 1,000. This plot shows the crosstalk for the RB-1090, and in this case the channel that is active is putting out about 5 watts into 8 ohms, and you can see that either the left to right or the right to left crosstalk is above 65 dB. There's a little dip here right at 60 hertz, but other than that it is better than 65 dB. There is no spec on the crosstalk, however, but just for information purposes, it looks pretty good. Here we have the multi-tone response of the RB-1090, and it's putting out about 5 watts into 8 ohms, and it's showing a distortion-free range of about 13 to 15 bits. This is a different variation of the multi-tone test, and the frequency range is from 20 hertz to 40 kilohertz. And in this case, I've applied a 19 kilohertz and a 20 kilohertz signal and adjusted their amplitude such that we have about 5 watts into 8 ohms. If you look at the reference point as 0, and we're down, worst case, about minus 80, which means we have about 13 bits of distortion-free range. This plot is showing the noise of the RB-1090. In this case, it is connected to 8 ohm loads, and both the left and right inputs are terminated into shorts, and we're seeing the noise level from 20 hertz to 20 kilohertz. There isn't really a spec, but there's an indication that the signal to noise ratio with A weighting, which I have, would be around 125 dB. We're at about minus 100 dBV, so we are doing pretty good for a 380 watt per channel amplifier. Here we have the THD versus frequency for several different power levels, and that's into 4 ohms for the RB-1090. The specification was that the THD should be less than 0.03%. Well, for several power levels, 0.03% would be below this line down here. So for these power levels, we are below that. But once we get to certain power levels, for some reason the left channel at 31 watts is up to 1% THD at least 1 point in the frequency band. But other than that, overall the THD would be less than 0.3% anyway throughout the band. So this graph shows the THD versus input level for the RB-1090, and this is just at 1 kilohertz, and we were using 4 ohm loads, and we are getting anywhere from 1.5 watt output, which would be an input level down here at about minus 21 dBV going in, and over on this end we're putting out about 500 watts, and we've got about 4 dBV going in. So the right channel looks better, and at worst case it's maybe 0.0007% THD at 1 kilohertz with 500 watts, and the left channel is maybe 0.08%, something like that, at 1 kilohertz with it putting out 500 watts into 4 ohms. For my listening test, I connected the RB-1090 into the system where my Sound Craftsman amplifier usually is, and that way I could see how it compares using the KEF 107 reference loudspeakers with its cube and all the other stuff that I normally have when I listen with the KEF 107s. The Sound Craftsman is an RA7501. At some point I will do a video on it. It's rated at 250 watts per channel into 8 ohms, so it is no slouch either. I listened to a variety of music and it sounded just fine. It doesn't add or take away anything to the music as best I could tell. I did play it very, very loud, and you will see a little clip here of the power meter, which I'll explain in a minute, as well as the sound pressure level meter at the same time, kind of giving you an idea. Now when I play that loud, for part of the time I'm closing my ears. Mainly I'm seeing how much power it's putting out, and then I'll listen for a little bit just to see if I hear distortion, which is going to be hard to do when you're hitting peaks above a couple hundred watts, which we were doing with this without any problem. There are no turn off or turn on noises with the RB-1090. It's fairly quiet. When you terminate the inputs and just listen to the amplifier coming out of the KEF 107s, I heard just the slightest amount of hum, very low level. If you're a few feet away from it, you don't hear it at all. But other than that, it's extremely clean amplifier. It never kicked into the protect circuit mode. As far as the temperature, it basically runs cool, maybe a little bit warm. As best I could measure around the solid part of the top and the sides, it got to about 105 degrees C. Now you have to realize that my listening room, it's summertime here in the desert, it's like 84 degrees, and so it's kind of already warm, and it got up a little bit warmer, as I said, 104, 105 most of the time. When you got cranking really loud for a longer period of time, it got a little bit warmer, but it was never hot to where you couldn't hold your hand on it for as long as you wanted to. Now, this little guy on the top, this is a power meter that I built a while back. It's a one of a kind. It uses an Arduino as the device that powers the LEDs. They change color from green to yellow orangish to red as you get towards the peak. I decided that I was going to calibrate the power meter to a certain extent. I used a 1 kilohertz tone and calibrated the power meter in a 4 ohm load. And basically when it hits that first yellow bar, you are putting out 55 watts. The second yellow bar is 137 watts. The third yellow bar is 220 watts. The fourth yellow bar is 350 watts. The fifth yellow bar is 450 watts, and that 6 yellow bar is 650 watts. You'll see the little video here with the SPL and the power meter, and it kind of just shows you how high I was cranking this guy. It didn't stress at all. I did have to readjust the KEF cube, which is an equalizer for the KEF, to bring back some of its response because I was getting a little bit of a resonance on one of the woofers. So I dialed that back a bit, but that's more related to the speaker than it is this guy. So he definitely can power the KEFs as much as I would probably want to drive them and be in the same room. It's a nice amplifier. I think it's built well, and even though it didn't hit the THD that the spec said, from almost 20 years ago, it still had a pretty low THD at the higher power levels, and it was quite respectable aside from that, and it drove 4 ohms just fine. It would be a nice amplifier to have as one's main amplifier for their system. My only nit probably, well, I have 2 nits. One is that this heatsink is just not really a heatsink, it's just for looks. It doesn't do anything really to take away some of the heat. Had I designed it, these would have been on the side as well to help take away some of the heat maybe, but they did a pretty good job, I think, overall in the design, taking away heat. Also, I like things with power indicators of some sort, or at least a clipping indicator. This does have just overload indicators. They didn't come on for any of my testing. I was drawing about 15 amps at one point during some of the real high power testing that I did into 4 ohms. But other than that, I think it is a really neat amplifier, and it would be great to have this in one's collection. Once again, I hope you enjoyed this video, and if you liked it, hit the little like button, and I would like to hear any comments you may have in the comment section. And if you have not subscribed, that would be a great thing to do to help this channel grow. And once again, until next time, have a great day or night.